All right, so now we're going to start matrices. We'll start off by saying that a matrix is a rectangular arrangement of numbers and or letters enclosed in a pair of square brackets or round brackets. So once you have a rectangular arrangement of numbers or letters enclosed in a pair of what? Square bracket or round brackets, what you have is a matrix. Now, a matrix is denoted by a capital letter. So I can say that this is the matrix capital A. I could say that this is the matrix capital B. A matrix is denoted by a capital letter. The plural of matrix is matrices. So that's how you get the word matrices. Now, the order of a matrix is the number of rows by the number of columns. Now, rows are horizontal. So if A is, let us say, the matrix 1, 2, -3, 4. If A is this matrix, A has 1 row, 2 rows. Rows are horizontal, and it has 2 columns, C1, C2. So the order of matrix A, the order is 2 by 2. The first number in the order is the number of rows. The second number in the order is the number of columns. So the order of a matrix is the number of rows by the number of columns. Guys, let's talk about the types of matrices. Now, first we have a square matrix, and a square matrix is a matrix in which the number of rows is the same as the number of columns. First, we have a square matrix, and a square matrix is a matrix in which the number of rows is the same as the number of columns. So the matrix A has 2 rows and 2 columns. So 2 by 2 is the order of matrix A, and we say that A is a square matrix because the number of rows is the same as the number of columns. We have a row matrix. Now, a row matrix is a matrix in which all the elements are in a single row. So B here, this is 1 row, and there are 3 columns. So this is only the 1 row, row 1. There are 3 columns, C1, C2, C3. So B, the matrix B has 1 row and 3 columns. The order of matrix B is 1 by 3. B is a row matrix because the entire matrix is a single row. Now, a column matrix is a matrix in which all the elements are in a single column. So C is the matrix AB is a 2 by 1 matrix. So C is the matrix A, B. This has 2 rows, row 1, row 2, and it has only 1 column, C1. So the order of matrix C is 2 by 1, 2 rows, 1 column. So the matrix C is a 2 by 1 matrix, and C is a column matrix. We have a singleton matrix is a matrix that has only 1 element. So D, which is this matrix, which only has 1 element, A, is a 1 by 1 matrix, and B is a singular matrix. We have the identity or I matrix. Now, the identity or I matrix is a matrix in which all the leading diagonal elements are 1 and all other elements are 0. So the leading diagonal goes from top left to bottom right. So the leading diagonal elements are 1 and all other elements are 0. Any matrix that is of that form is called an identity or I matrix. So I, which is the matrix 1, 0, 0, 1, is the 2 by 2 identity matrix. We have the 0 matrix, so all the elements are 0. We have the diagonal matrix, only the leading diagonal elements. The leading diagonal elements are not 0, and all other elements are 0. We have the upper triangular matrix, and you guys can look at that, and the lower triangular matrix, and you guys can look at that. Now, in matrices, this term is important. It's an important term in mathematics in general. The idea of commutativity and associativity. Now, an operation star is commutative on a set A if for all A and B, which are elements of the set A star B is equal to B star A. In other words, the order of the numbers in the operation does not influence the answer. So that is the word commutativity or commutative. So I'll give you an example of this. 3 times 4 is 12. And 4 times 3 is 12. So therefore, 3 times 4 is the same as 4 times 3. What this means is that now this is also true when you multiply all integers. Once you multiply integers and you turn around the order, change the order of the numbers, the answer will still come out to be the same. So what we say is that the multiplication of integers is commutative. And essentially what that is saying, the order in which I multiply numbers does not change the answer. Once it's the same numbers, it doesn't change the answer. Now, when an operation behaves like this on a set of numbers, we say that the operation is commutative. The next word that we need to bear in mind is the word associative. All right, the next word we need to bear in mind is the word associative. Now, an operation star is associative on a set A if for all A, B, and C, which are elements of the set A star, B star, C in bracket is equal to A star B in bracket times, star C. And what this is saying is that grouping does not influence the answer. So in the first instance, I was grouping A and B. They're in the bracket, means that you need to work those out first. In the second instance, I'm grouping A and B. They're in the bracket, means that you need to work those out first, but yet the answer came out to be the same. All right, let's have a look at a scenario. Let us say 2 plus 3 plus 4. This is the same as saying 2 plus 7, which is 9. Now 2 plus 3 plus 4, this is the same as saying 5 plus 4, which is what? 9. I changed the grouping, but the answer came out to be the what? The same. The grouping is talking about what do I add first. I changed what I added first, but yet the answer came out to be the same. This is telling me that the addition of integers is associative. All right, so 2 words we need to bear in mind, the word commutativity and associativity. The word commutative and associative. Commutative talks about the order in which an operation is performed, the order of the numbers when you're performing an operation. If you change the order of the numbers and the answer comes out to be the same all the time, we say that the operation is commutative. If you change the grouping and the answer comes out to be the same all the time, we say that the operation is associative. guys, next we're going to look at the addition and subtraction of matrices.